All right, so we're in section 2.7. We're going to graph rational functions. So, like I said, we don't really need to add any new information. We just need to kind of consolidate everything we've talked about with rational functions. So, our rational function, n of x numerator over d of x denominator, and n of x and d of x are polynomials. So, we're going to list some guidelines, and then we'll go through some examples. So the guidelines are just what we need to do to help us sketch the graph of a rational function. First, and we don't have to go in this order. This is just how I happen to write them down. We find the x-intercepts, and how do we find the x-intercepts of a rational function? When y equals 0, and for a rational function, what makes y equal to 0? The numerator is 0. So to find when the numerator is equal to 0, usually we end up factoring the numerator. Second, it can be helpful to find the y-intercepts. We want to know where it crosses the y-axis. How do we find the y-intercepts of a function? Plug in 0 for x, because on the y-axis, x equals 0. So we're going to plug in x equals 0. That's how we find our y-intercepts. Find our horizontal asymptotes. And for our horizontal asymptotes, we just use our rules, our 3 rules for horizontal asymptotes. I'm not going to rewrite them up here. So our 3, when we look at the powers of the numerator and denominator. So we use our rules. Number 4, find our vertical asymptotes. And the vertical asymptotes, how do we find those? When denominator is 0. And we usually factor to find the zeros of the denominator. We also, the domain restriction. The domain restriction is either going to be a vertical asymptote or a hole. But yeah, that's a good question. If something, the things that we leave out of the domain are where we get our vertical asymptotes. We also need to check for holes. So where do we find a hole? D of x equals 0, n of x equals 0 at the same time. So we end up with a common factor in the numerator and denominator. And always with rational functions, we have to plug in some additional points. So just plug in some numbers into our function to find additional points. So I'm going to say additional points. Between and beyond asymptotes. Because our function can do, or rational functions can do all different kinds of things around the asymptotes. And then the last little piece, not really something that we have to find, but just a bit of information. Our rational functions can cross horizontal asymptotes. cannot cross vertical asymptotes. Because at the vertical asymptotes, like Dylan asked, that's where the function is undefined. It's undefined there, so it can't cross a vertical asymptote. We're restricting that number from its domain, so we get rid of it. So all I want to do is go through a couple of examples of sketching some rational functions, and then there was one piece we talked about when we don't have a when we don't have a horizontal asymptote, and I said you get a slant asymptote, and we've talked today about how we find that. So I'm going to do one example with a slant asymptote. So questions on our guidelines? Okay. So let's start with an easy one. So all of these we're going to sketch x plus 1 over x. So let's find our information. What do we want to do first? I don't care what order we do it in. What do we want to find first? Start with 6. Okay. Well, it can't. So we know it can't cross a vertical asymptote, but it can cross a horizontal asymptote. So we'll just make a note of that. Okay. All right. So next, what's that? Asymptote. So let's do. Want to do a horizontal first? Horizontal asymptote. Compare the powers of the numerator and denominator. How do they compare? They are the same, so that tells us that the horizontal asymptote is y equals, what do we do when the powers are the same? Leading coefficient. So we have 1 over 1, y equals 1. And remember, our asymptotes are always lines, so we have an equation of a line, y equals 1. Vertical asymptote. Vertical asymptote is when, what happens? X equals 0. The denominator is equal 0. So we have a vertical asymptote at x equals 0. Intercepts. X-intercept. When what happens? X plus 1 equals 0, so x equals negative 1. Y-intercept. Plug in x equals 0. What happens when we plug in x equals 0? It's what? If I plug in x equals 0? Undefined. Because we have a vertical asymptote there. So that tells us there's no y-intercept. So now we're ready to start sketching our graph. Horizontal asymptote at y equals 1. So I'm going to say there's y equals 1. Vertical asymptote at x equals 0. So they're along the y-axis. We know our x-intercept is at x equals negative 1. So right there. And now to figure out what my function does, here, 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 whatever, I need to plug in some points. So I just calculate. Plug in some points and calculate. I'm not going to do all the calculation, but if we plugged in x equals negative 2, I would get a point here. If I plugged in x equals 3, I'd get a point here. If I plugged in x equals negative 1/2, I get a point down here. So that tells me my graph here looks like this. And then on this side, I plug in x equals 1. I plug in x equals 1, I get y equals 2. So I get a point up here. If I plug in x equals 2, let's say I get a point there. So my graph is going to look like this. If you're not sure, plug in more points and calculate. Just plug in x values, make a table of values if you want to, and plug in some points, calculate and plot points. Yes?
What does our textbook say the sort of vertical blackness?
Vertical should be undefined. I don't know what the textbook says, but it should say undefined.
I was just wondering, because depending on Sometimes we'll have to answer it.
I always say it's undefined. Because you could say it's infinite, but infinite's not really a number.
Right.
All right, questions on that graph? So once we find our asymptotes and our intercepts, just plug in some numbers and calculate to get the shape of the graph. All right, let's look at one that's a little more interesting. Oops. Let me do that. G of x equals x minus 2 over x squared minus 2x minus 8. And we want to sketch a graph of this rational function. So what's going to be the first thing that we want to do here before we even start finding things? What is it? We want to factor the denominator. So because we need to know when the denominator equals 0, factoring is going to help us out. So how are we going to factor that? X minus 4 x plus 2. All right. So now we can start finding our information. What do we want to find first? Horizontal asymptote. The denominator is larger. So what does that tell us about a horizontal asymptote? Y equals, remember horizontal asymptote is the equation of a line. Y equals 0. Vertical asymptote. Where are vertical asymptotes going to be here? 4, what equals 4? X equals 4, equation of a line, and x equals negative 2. Let's find our intercepts. X-intercept when x equals what? 2. When the numerator is equal to 0, 2. Y-intercept, plug in 0, so we can write this out. So we get negative 2 times negative 4 times 2, which is 1/4. So y-intercept is y equals 1/4. Don't have any holes. Don't have anything else we have to worry about. So let's sketch this one. Our horizontal asymptote y equals 0. They're on my nice straight y-axis. Vertical asymptote at x equals 4. Vertical asymptote at x equals negative 2. We have x-intercept at x equals 2. We have a y-intercept at 1/4. Y equals 1/4. So from here, we need to plug in points and calculate. Because our rational function could be here, could be here, could be here, could be here, could be up here, could be down here, could have a cotangent shape. So we just need to plug in numbers and calculate. Plug in numbers to our function and calculate the y values. If we plugged in y equals negative 1, I'm not going to calculate it all out. If we plugged in y equals negative 1, we would see that we get a point here. If we plug in x equals, where are we at? 4. If we plug in x equals 3, we get a point down here. So our function is going to do that. And then we need to plug in numbers beyond our asymptotes because our function could be here, could be here, here, here. So I plug in x equals 5 and I get a point here. Plug in x equals 6, I get a point here. So our function is going to do, our graph's going to do this. Same thing over here, I'm going to plug in x equals negative 3. If I plugged in negative 3, I'd say I'd get a point here. Negative 4, I get a point there. Negative 5 there. So my function does that. And we could put arrows on because it keeps going. And if you're not sure, just plug in more points and calculate. Yes? Nope, these are the only ones. So the only time you get a vertical asymptote is when the denominator is 0. Those are the only possibilities. And we know that our function doesn't cross the horizontal asymptote here because there are no other x-intercepts. So it doesn't go below the x-axis because there are no other x-intercepts. It can't cross the x-axis anywhere else. Yes? Yeah, it can happen that way. You can get functions that where the graph looks like this. So you have y equals 0 as a horizontal asymptote, goes up and then back down. That does happen. All right, any other questions on that one? All right, let's take a look at how we deal with a slant asymptote. So for this function, we have y equals x squared over x minus 2. So we're going to follow our guidelines and get our information about our function. So what do we want to find first here? Vertical asymptote. That's an easy one here. Where's our vertical asymptote? When what happens for a vertical asymptote? X equals 2 when the denominator equals 0. How about a horizontal asymptote? The degree of the numerator is larger. What does that tell us? What is it? So the numerator is bigger, so there is no horizontal asymptote. We would get y equals 0 when the denominator is bigger. So we'll come back to this in just a second. X-intercept. X-intercept when the numerator is 0. And y-intercept when we plug in x equals 0. What do we get when we plug in x equals 0? 0. If x equals 0, I get 0. So if the x-intercept is x equals 0, the y-intercept is y equals 0, what point does that tell us this graph goes through? It goes through the origin. So that tells us we go through the point 0, 0. Through. All right, so we don't have a horizontal asymptote. The degree of the numerator is 1 more than the degree of the denominator. That tells us we have a slant asymptote or an oblique asymptote. So when the degree of the numerator is 1 more, the degree is 2 in the numerator and 1 in the denominator. It could be 3, and 2, 4, 3, etc. Just has to be 1 more than the degree of the denominator. We find it with long division. So, because it tells me to divide, so I'm going to divide x minus 2 into x squared plus 0x plus 0. So we do our long division here. What do we have to multiply x by to get x squared? X, put that up there, and I get an x squared minus 2x. Subtract, so I get a 2x plus 0, bring that down. What do we multiply x by to get 2x? Multiply by 2, so I get 2x minus 4. Subtract, and I get a 4. And I can't divide anymore. So this tells me that x squared over x minus 2 equals x plus 2 plus 4 over x minus 2. As x gets really, really big, what's going to happen to this fraction? If I divide by a really, really, really big number, it gets smaller and smaller and smaller. So as x gets really, really big, this becomes less and less important, and all that's left is x plus 2. So our slant asymptote is what is left up here on top when I do long division. So this tells me that y equals, the line y equals x plus 2 is a slant asymptote. So now we're ready to sketch our graph. We have all of our information that we need. Our vertical asymptote is at x equals 2. Our slant asymptote is y equals x plus 2. I need to graph that. How do I graph that y equals x plus 2? Plotting points, and what this is in y equals mx plus b form. So what does this 2 tell us? That's the y-intercept, so it crosses at 2. The slope is 1, so I could go plus 1 over 1, etc. So there's my slant asymptote. We know the graph goes through 0, 0. And then to figure out the shape, we would have to plot some points. Plug in some numbers in here. And what we would see is function does this, and the function does that. And we would figure out that shape just by plugging in some points and plotting points. So our slant asymptote we find by long division. Whatever is left up here, y equals that, is our slant asymptote. We could have quadratic asymptotes, we could have cubic asymptotes. We only talked about the slant asymptotes, but they do show up, and that just means the graph will get close to the side of a parabola as it got bigger, or the side of a cubic function as it got bigger, the side of the 4th degree polynomial as it got bigger. Yes?
How do you determine the
So if we would have a quadratic asymptote if the degree of the denominator or the numerator were 2 more than the degree of the denominator.
Okay.
It would be cubic if it were 3 more.
Okay.
So because it's 1 more, we get linear. So the 1 tells us the power on the curve that makes the asymptote. Okay? The degree of the curve that makes the asymptote.
So you just define those asymptotes with the same method.
Yep. Long division. Whatever's left on top is going to be our asymptote.
Right.
Yeah, exactly. Yeah, Paolo.
Why did you pick x minus 2 to the long division?
Because our original tells us to divide x squared by x minus 2. That tells us to do division. Okay? All right, those are good questions. Good questions. Okay, homework. All right, there we go.